Hello, one and all, and welcome to Learn CNC with Javi. Give me a moment here while we wait for some people to come in. Wait for everything to populate, and we'll start the show. Tonight's broadcast will be all about feeds and speeds on the CNC. I'll be showing you how to create a little template to test your feeds and speeds, and so on and so forth. So, como? How's it going, DJ? Just waiting for people to come in, and we shall start the show in a couple minutes. Mr. Matt Haas, how are you? Just type in here. Dave's here, so we can begin. That's a beautiful thing. Oh, folks, I'll give it one more minute for a few more people to come in. Hello, Reginald, Dave, Matt, EJ, how's everybody? As I was mentioning, tonight we're going to talk about feeds and speeds. I'm going to give you a little template, show you how to create a little template to test your feeds and speeds, and answer any and all questions you have about feeds and speeds. The only question I will not answer is what's the perfect feed and speed, because that is a trick question. So, well, evening, Joe. I guess we'll begin. All about feeds and speeds. When I first got into CNCing, woodworking CNC, one of the biggest questions I had, and I'm sure all the newbies have this question all the time, and some of the veterans as well, is at what speed should I be running at any particular project? And no one likes to hear it, but it depends. I mean, the short answer is you have to test your bits, you have to test your wood, the particular species of wood. If you have samples, you have to test your project, and try different feeds and speeds to see what cuts the best. The slower you go as far as feeds. Okay, let's talk about feeds first of all. Feed is the rate at which for those of you who are unaware, the rate at which your CNC moves back and forth, left and right, up and down. And the speed is referring to the speed of the bit, how fast it's turning. Now, for those of you new to CNC, it is highly recommended that if you want to come up with a number, 8 to 12,000 for most jobs is an ideal speed. You don't need to go any faster than that. Sometimes I've heard some friends of mine, and I do it as well, if a bit is a little dull, or it's getting a little dull, and I'm not going to sharpen it, and I haven't invested in a new one, it's a job that I don't really care too much about or something, I'll speed it up a little bit more. It doesn't always give you a better cut, but often it compensates a little bit. Now, be aware, the faster you go, the more likely you are, the more faster you go on the speed, the likelier you are to burn the wood. The slower you go on the speed, the more likely you are to get tear out, to rip the wood. Obviously, that's tear out, and to bog down the machine, because if you go too slow on the if you're going at a real fast feed rate, and a very slow speed, you could actually crash the machine. And feeds. As far as feeds are concerned, the faster you go on a feed, if you go too fast, a lot of people are fond of saying, "Oh, well, I want to get the fastest machine I possibly can. I want to go 800 inches per minute." Well, that's fine if you have a milling machine, but that's got a very sharp bit and that's meant for industrial use. But for a hobbyist CNC, anything past, I've never really had to go. My machines are more than capable of 600, and whether it's the Cam Master or the Gatton, they're easily capable of 600, and I will not go past 150. In fact, most jobs I have, it'll be 80 to 120 is the feed rate. Depends. There are a lot of exceptions where I'm going 20 even. So let's get to the test. Hey, Jim, how are you? And Paul. I'm going to create a little template here. Let me share the screen with the folks. And I'm going to create a quick little template here for testing feeds and speeds. Now, the template is nothing more than a bunch of straight lines, and they're going to create a simple pattern here. Let me show you explain what I'm talking about here. So I'm going to take and do one straight line here, and then I will do another straight line here. These should be two separate lines. They should be. Let me see if they are. Yeah. These are two separate lines. Here's what's going to happen. What's going to happen is I have to center my... Okay, so... Yep, can't feed faster than the... And now there are a lot of different... there are a lot of different chip calculators out there, and when I was brand new and didn't know anything about CNC, I started looking at all those chip calculators, and this, look, that works fine for aluminum, but for wood, forget it. Just throw all those chip calculators out the window. They may get you close if you want to invest all that time, but frankly, I found that this little test is very convenient. I'm going to look now at the nodes. See, I want this to start over here. So I'm gonna make a start point up here. Make start point. So this is gonna start the bit up here and go all the way down to the bottom here. And then actually, wait, let me see. Which one was the one I created first? I created this one first. I'm sorry. I'm going to make this the start point of this line. And then when I take this line here, I will make this is the start point. So here's what's going to happen. In order, the bit will go from here to here, and then it will start this line from here to here. So, okay, you may be asking yourself, why are you drawing one straight line? Well, this is what I'm going to do. First of all, I'll take this bottom line and create a fluting toolpath. And we will ramp over the complete length. So here's what happens when I'll start at 0, and I have a sample piece of run it wide open, it cuts better. That's funny, Russ. And then it creates nice fires better that way. So then create the flute depth down to, I'm going to go all the way down to the bottom here, down to the full depth, which is 0.75. So from here to here, I just ramped it from 0 to 0.75. Now, okay, calculate. There's my first fluting toolpath. Let me leave this up here. And then what I'll do is, on this one here, I'll create another fluting toolpath. Second. There we go. And we shall make it from 0.75 to 0. So those of you who are following along know exactly what I'm doing here. I'm having the bit go, well, let's see. Let me see if it, nope. This one did not work right. Okay, sorry. Start depth is 0. Flute depth. Let's see, it should go up. Let's try this one and see what happens. Let me see something here. I'm just playing around with this for the moment. Okay, this one's going correctly. This one should go back up, and start depth is 75. Flute depth is going to be, let's try negative 0.75 and see what happens. I didn't think so. Well, we'll have to reverse this one. Either way, the let's I did this last time. Let me try something else here. Let me catch up with the chat feeds and speeds. For Dave, are these for horizontal or vertical CNCs? They are one and the same. So jacking up everything to the max is not advisable. Definitely not. That is a sure way to ruin your bearings, to burn out your bits faster, to start fires. I can go on and on and on why it's why it isn't the best idea in the world. There are, you know, if you're a true CNCer and not just you know, one day a month, just throw it on there, then take care with your feeds and speeds. Let's see what happens to tooling when you're running into a piece of yeah, ductile iron. Okay, so let us do this. Ramp at start and end. Okay, there we go. That's what I wanted. All right. Let's go back to this. Remove this. Forgive me, folks. It's been a couple of years since I've actually created this file. So I'll take this, and all you need is one line. Create the fluting toolpath the following way. Delete this. And you're going to create it by doing ramp at the start and at the end. So it's going to go down to the full depth, and then it's going to go back up. So if you calculate it and you preview the toolpath, this is what it's going to do. Your bit is just going to go down all the way and up. Seems pretty simple, straightforward. Now here's what we're going to do. We're going to create multiple lines, and we're going to do them at different speeds, each one. So let's take this line and duplicate it. Create linear arrays. We'll create, say, let's see, 10 columns is, yeah, we'll try 10 columns. And we'll put them nice and separate from each other. And that's the first one. The first one we'll edit, and we'll do speed rate of 10 inches per minute. And by the way, plunge depths also come into play. And now we'll, let me see, sorry. And then calculate We'll do the same thing with the second one now. This is a little tedious, but you get the idea. In the end, what you're going to have, well, let me do the second one, and then I'll show you the rest of, I'll just duplicate for the rest of them just to save some time here. Go to the fluting toolpath, just hit calculate. It's the same fluting. And then on this one, choose it and go a little faster. Say the feed rate is now, put 50. I like to do increments of 10, 20, 30, 50, 100, 120. Do 400 if you like. Whatever floats your boat. This is strictly a test. And in the end, you're going to see a bunch of lines like this. Now, create this is a sample of a 12 by 12 piece. You could put the lines closer together, whatever the case may be. Let me quickly just show you what the end result will look like. So in the end, you're going to be left with, you're going to do 10 of these tool paths and run them all together because it's going to be the same bit. And you're going to end up with something that looks like this. Now, it's not going to be this nice and smooth. You'll see when it's really, really fast, you're going to see a bunch of tear out over here, depending on what you use. If you're using melamine, you're barely going to see a difference because the melamine, if you've got a sharp bit at any speed, it shouldn't tear out. If you're cutting with plywood, you will definitely see a difference. And you could decide, at the end, you label your thing, you put 10, 20, 30, 50, 80, 100, 120, 200, 300, 500, whatever the case may be. Let me catch up on the thing here. I'm reading up on the as you can see, following along with the cursor. Yeah, if you like replacing spindles, that's definitely the way to go. Is to run it at full bore. And so anyway, so that being said, there's your test pattern. It's a nice, simple test pattern to do. Now, does anybody, while I'm here, have any questions on feeds and speeds? Any general questions? This will give you a general idea. This little board, replace the board with a small piece of cherry, of poplar, of plywood, of whatever you're using for your projects. Take a small piece, create this as needed. I'm currently using a 1/4-inch bit because if you're cutting with plywood and you want to get nice clean cuts, like I'll use Dave Gatton as an example. When he's cutting his CNCs, he wants to know the maximum speed that he can possibly use to get a super clean cut while not having to waste a bunch of time on cutting the parts. Well, this is one way to go at it. Take your 1/4-inch bit, run it at different speeds, and you can see if there's any tear out. If you find that at 200 inches per minute, the bit is the spiral bit. Yeah, that's short for spiral bit, spit. The spiral bit is going real quickly, then by all means run it at full speed. But keep in mind, you're taxing your machine, but you are saving time, and time is money. With this particular project, you can use V-bits. I mean, any bit you have, bullnose, roundovers. Roundover bits. You use V-bits. You use dish cutters, even surface cutting bits. Although I wouldn't run those past 1/10 of an inch. If it's an 1.5 inch thick blade and you want to see how fast a surface cutter cuts, don't go past 1/10 of an inch, or 30 or 40 inches per minute. Unless you have one heck of a very powerful machine and feel like breaking bits. That's another thing that can happen. I've mentioned a number of things that can happen if you go too slow. One of the things that can happen is you're creating so much force on the actual wood that you can actually chip a blade. Likewise, if you go too fast, you can end up chipping a blade. Although that says more about the quality of the blade than anything else. Running a tooling into a spinning chuck makes really neat noises. Yep. Destruction of the machines. Gotta love it. Let's see here. So, do I generally... Okay, let's see. Does Mach 3 or similar have overspeed warnings built in? No, they do not. When you're working with industrial machines, you have... depending on the spindle you're using, and most of the time it's more with servos than with that's one slight advantage of servos, but they're very expensive and they're more for industrial machines. You actually have you can get feedback as far as the torque and things like that, depending on your machine. Some machines have those capabilities built in, so you can know exactly what the maximum speed is without having to go through this much test. But that's just as far as torque. As far as, I'll use the word cuttability, that remains, you have to test it out. There is no substitute to putting the time in and testing your pieces of your sample pieces with your bits. And even that's no guarantee. And I would not, if you find an optimal speed, a maximum speed that works really well, I would bring it down a notch from there. Because as it's been said many times, every wood is different. Every grain of wood, just because your sample wood, which happens to be identical to your piece, to your final piece, doesn't mean it is. I mean, might have a knot in it or something, or a slight variation on the grain that is just enough that if you're running it at full speed, it'll make the difference. Another note on feeds and speeds. One trick to getting a clean cut that I like to do is when I'm doing a 3D project, or pretty much any project, whether it's a V-carve sign or a 3D project, particularly for V-carves, I tend to run it at full bore. I mean, I tend to go when I'm in a hurry. Again, I don't recommend it, but I do it anyways. Just do what I say, not what I do, or whatever. The machines I run it as fast as I possibly can, knowing I'm going to get a little bit of a tear out. Again, it depends on the wood. If you get a lot of tear out, nothing will fix it. But if you get just a tiny bit of fuzz, I run it super fast. And then what I do is I slow it down just a tad and just drop it 1/100th of an inch, the Z, and run the program again, run the final program. If you get good at programming the machine, you can actually do it all in one path. I mean, in one blow. You program the tool path, you run the V-bit tool path, and then you run the final tool path 1/1000th of an inch lower, so it'll just skim the top and clear out all that fuzz. Sometimes I even run it twice real fast, and that second time clears it out. But what I've found is it's a 50-50 shot, and most of the time it doesn't work. It will leave a lot of fuzz, even the second time. Again, running it full bore sometimes works. These are a bunch of different techniques that you have to try. What I have found works the best is run it at a slower speed from the beginning and shave off a tiny little bit of skin. In other words, whether you're cutting a profile and then you do an inset, or you're doing a V-bit pattern and then you drop it down. That's the best advice I could give. Is just uh, do it that way. Taking little bits out, little bites works best. By far, the best and cleanest way that you will avoid all sanding is taking tiny little bites, 0.05, 0.03 per pass. The downside of that is you're going to be putting a piece on there for hours if it's a large piece. So you gotta deal with the balance. Let's see if we have any questions. Do I run the spindle at the maximum speed the cutter is rated for? At times, but most of the time I don't. Again, I personally, I run, like I was saying, between 80 and 120 and between 8 and 12,000. So between 80 and 120 inches per minute is a good is a good average for many jobs, taking off 1/10 of an inch at a time. But I have run this machine at 300 and 400 inches per minute with a 1/4 inch drill bit, 1/2 inch shaft, real strong, a spiral down cut, taking off plywood at in one pass. So 3/4 of an inch thick. I don't recommend it. It looks like garbage because it just shreds the piece. But I've done it just to see that I could. If you have a brand spanking new bit, it produces a clean cut. But that 2 or 3 jobs later, you're not going to be cutting at that speed without tearing out. It's just there's no way to avoid tear out when you're cutting at those speeds. It's ridiculous because the bit itself, no matter how fast it cuts, you're just pushing the wood along. It doesn't give it a chance to cut correctly. So let's see here. Yeah, Frankie, that's a good way of doing it, is starting at 80 and bumping it up. If I have jobs that I want that are really detailed and I'm working with then I might go down to 30 or 40 inches per minute, which seems incredibly slow. But they tend to it tends to be a much cleaner cut. And figured wood would not be a good idea to use. Let's see, Tom. What? Yeah, Jim. All your CNC experience has been with the metal industry. It is there are similar aspects between metal, and I've worked with metal CNCs before, and I'll tell you, with metal, there are 2 different schools of thought with metal. One of them is cut slow and light and take nibbles. Another one is cut really fast with a sharp bit, and it has to be at the right speed. And that way, the cut itself, nice big chips will cool the bit as fast as it's traveling. Run a lot higher risk of breaking a bit that way. But when you're cutting aluminum, and I'm talking about aluminum, and I'm talking other metal. I haven't worked with other metals. I've done high speed steel every now and then on occasion with the rotary engraver, but for the most part, I've worked with aluminum, and it's and then there's the other aspect when you're working with metal CNCs is the finish that you want on it. Because sometimes for some people, finish is important. They don't want to see this random pattern. They want a last pass to be, just a beautiful little swirly pattern. And that again takes a little bit of artistry and a little bit of programming. But we're talking about, when we're talking about woodworking, what you want to try to avoid is chips so big that you're splintering the wood. You're not actually making chips, you're just tearing out pieces of the wood, or so small that it's dust. If you're seeing dust instead of chips coming out of your machine, you're going at the wrong speed. Or you're using or you're going at the wrong speed. And if you're not seeing chips, you're seeing tear out when you go at a slower speed, and you have it's either dust or tear out. Then you don't have a sharp enough bit. I mean, it's pretty self-explanatory. I mean, common sense. It's not so common. I'm looking forward to seeing the halftone photo of the wife. One of the things that I'll be planning on doing, well, who knows, hopefully by the end of this year, is I want to create I'm going to build a standalone lathe CNC. And I was looking at some of the projects out there. I saw someone made it was beautiful, a lithopane or lithograph or whatever you want to call it, on a PVC tube, not a PVC flat, PVC tube. So, I mean, that's a pretty simple thing to do. All you have to do is you take the normal artwork that you would normally put on a square, calculate the circumference of the PVC, put it on the lathe, and it'll translate directly. So as long as you get the depth just right, and making sure you have that PVC centered perfectly on the lathe, and that's a simple matter, because all you have to do is drop the bit down, rotate it all, make sure it's always even. Then it should be a pretty simple process. But I've yet to try it, so that's going to be something fun to experiment with. On a different subject, before I forget, there are 4 days left. What day is today? The 26th. There are 4 days left for the Useless Challenge. If anybody's not entered, I haven't had time to even promote it, so I understand if anyone else hasn't had time to go on it. So if you don't do it this year, come up with some ideas starting now for next year's April challenge. And for those of you that have entered, thank you for entering. And we'll be looking at in May. We'll be looking at all your videos and seeing if we get a kick out of it. Don't concentrate if anybody's still. Hey, I think we have 1 or 2 entries, and we have 3 or more prizes. So you're guaranteed to win if you enter now. And if you do enter, don't concentrate on so much on the useless part of it. The main emphasis is to make it funny. So, try to do that. So that's the Useless Challenge. It's on my channel. Go take a look at all the, rules and all that stuff. On javiswoodshop.com. I'm sorry, on the YouTube, Javi's Woodshop, and this channel. And let's see what else. Starting next week will be my final week on Thursdays. I'm going to there's going to be a playlist, Dave. For the Useless Challenge. I haven't again, I'm as busy as the people that haven't been able to enter. They'll all be on a playlist pretty soon, and I'll be putting them all up. I've gotten, like I said, 2 so far, so it's going to be a very small playlist at the moment. And starting next week will be my last week on Thursdays. Following that, on May 12th, because I'll be out on May 5th. I won't be around on May 12th, which will be a Saturday. We're moving the CNC with Javi show to after Dave's show, because a lot of people have been complaining that they're saying that they don't have time on Thursdays. It's a difficult day, and they'd rather do it on a weekday. I don't want to be stepping on anybody's toes or anything. And I figured, well, since I'm usually moderating for Dave anyway, as soon as that show's over, we'll start the Learn CNC with Javi. This show will be a little small today because we're going to end way before 9 unless you guys have a lot of questions, because feeds and speeds is not really a big issue. I mean, it's pretty straightforward. Try it yourself. Try all the different feeds and speeds. Let's see, what else do I have? Anything to mention? For those of you, and I don't have, unfortunately, I don't have the. Let me see if I can find the link for you guys. Jerry Blakesley has had some setbacks, we'll call it. He had some issue with tetanus. He's doing better, and his family could use your help, and they have set up a GoFundMe page to give him a hand. So please, if you can, let me give you guys the link here as soon as I find it, and let's see if. Bear with me while I try to pull it up. Steve was unavailable tonight, so here, back and forth. Okay, what was it again? Facebook. All right. And this one. Have I got my pulley system installed? Keep asking, because one of these days I'm actually going to say yes. No, I don't yet, Dave. I'm still trying my darndest to get some time so I can go out there and do that. Oh, by the way, here's the video for the almost useless challenge. While I'm here, let me give you guys the link for Jerry. There we are. Stand by. So if you guys can, good cause. It's always a good cause. We always, that's the beautiful thing about our maker community. We support each other in times of need. Let's see if I have any more questions here. Pulley systems. Do your machines have a percentage feed dial so you can adjust it on the fly? Yes, the Mach 3 has a. For those of you who haven't played with it yet, and oddly enough, I was familiar with WinCNC when Master Dave Yoda Gatton was on a hangout with me and telling you, well, why don't you reduce the speed? Or I didn't know Mach 3 could do that. I could do it on the other one, but and sure enough, Mach 3 has that. Where it shows the speed, there's a little arrow. You can go up and down. You can set the dial up and down, and you can set your feed rate. You can bump it up or down by percentage. Hey, Patrick, how are you? So that's a good way to adjust your feed rate on the fly in case you're seeing that it's tearing out. You want to slow it down a little. You're seeing that it's burning the wood. You want to speed it up a little, and those kind of things will are good. Mach 3, if you have gone that far, it has the capability of controlling a spindle speed rate, or with a little bit of electronic know-how, also a router speed controller. You can actually control it with these Chinese spindles. You can control it directly. All you need is the breakout board, a couple of wires, and a couple of internal settings, and you're done. And you can actually control the feed rate. It's well, for those of you who are interested, it's a 0 to 10 volt signal that goes into the VFD, which tells you whether to go from 0 all the way up to full 24,000 or whatever your maximum RPM is. And you can control it through Mach 3. I advise against it. Reason being, it's not as easy as the feed rate to control your speed on the fly. And when you're, unless you program it exact on every job and know exactly what you're getting into as far as the feed rate, you're better off with the manual controller, with a dial, with a simple dial. You have a dial ready and waiting, just like when you're in the old days, in the manual days, when you're handling a router or when you're at a router table feeding the wood, when you're feeding something, when you're the I hate it when that happens. Pardon me, folks. I'm getting my Windows back up. I hope I'm still broadcasting because I can't tell because I could see my broadcasting window, but I can't see the chat. So bear with me. And there we go. There we go. All right. So I'm back. Yeah. Gotta be a Mac. Leave it to Dylan. All right, let me scroll back and see. Yeah. For those of you wondering about a couple years ago, a hard drive. I mean, this hard drive was 4 or 5 years old, the internal hard drive, and it crashed, and I replaced it. Unfortunately, I replaced it with a 5600 RPM instead of a 7200 RPM, and Macs, they need the top of the line, or they're not going to function perfectly. So that is what happens on occasion. I get the old crash. Jerry Brown, while you're in here, do me a favor and shoot me through Messenger. Shoot me your address. I have. Remember last year how Jerry, you won one of the little awards here? I finally got around to it. I sent Nick his award from last year from the Useless Challenge, and I'm well within the 1 year mark. So that's good. That's a good thing. Let's see how. All right. So where was I? I completely forgot. I was back to we were talking about feeds, and I was saying that the just how you have a manual router or a router table that you're feeding the wood through. You could feel it in your hands. You could feel it when it chatters. If you're going too fast, it chatters. You also can hear the sound. The thing that surprised me the most about a CNC is I thought no matter what, it's going to be a perfect cut every time because it's a machine moving it, and it doesn't need any assistance from me. And the second thing, one thing that I was surprised was, one, the lack of the difference in the sounds. You can hear them when you've been working with a CNC long enough. You can hear when it's cutting right, when it's cutting wrong. You can hear it when it's chattering. You can hear when it's going too fast. You can hear it when it's crashing, when it's bogging down. And there are a lot of sounds that come to mind, but you don't have the feel, obviously, that you have when you run a router manually. So that's why you should practice on, and I can't emphasize it enough, on various pieces of wood until you get the hang of whatever particular material you're using. And even if you're comfortable and you've been doing this for years and you're comfortable with let me respond here. Even if you're comfortable with the CNC and you've been using it a certain way for a long time, don't get complacent. I mean, go back and take a look again, and you may find you may be surprised and find that I know I'll share a story about Drew Ox in the shop. He was using his CNC just to cut simple patterns. His Gatton, his GarageWorks, by the way. It's a beautiful GarageWorks. See Dave Gatton at davegatton.com for yours. And he was cutting plywood with it, and that's it. And he was doing some V-groove signs. But he asked me, we did a collaboration, and I did a design for him, and I sent him the toolpath. Now, the toolpath I sent him was running at 120 inches per minute, because that's what I'm used to running at, and I didn't know any I didn't know. I mean, that's based on the tool that he had, the bit that he had, what he was cutting, and the capabilities I knew that the machine was capable of. I figured, well, 120 is a good rate. Well, Drew was used to running at 50 and 60, and he goes to me, I've never seen the machine go that fast before. You know, and that's the thing. He'd never tried it faster because he didn't know it was capable of more. Go ahead and push your machine not past the max, but inch up. And likewise, try the lower speeds for accuracy and for cleanliness, and find your balance. It's all about balance, folks. Let's see here. Any last minute questions before we adjourn? Ragging out on the live feed. Yeah, see, I don't pay attention to any of that talk because Google Hangouts is just notorious for being a resource hog, and everybody knows it. Let's see. But it's the best that we got. Let's see. Good thing the sawmill and this. Yeah, sawmill is nice. Ooh, a kiln. Thanks, Steve, for putting it up. And again, I'll go ahead and or Steve, if you want to put up again Jerry's link one more time, just if anybody came in late. Jerry Blakesley, help if you can. It's always a beautiful thing to share for those who are in need. And well, so thank you all for watching. If anybody has any last minute questions, by all means, about feeds and speeds, put them up there. And if you missed the first part of the show, it's a nice little use a little fluting. I showed you how to make a little fluting toolpath, a bunch of little strips, so you can set them at different speeds and test your bits. Put a V groove in there and test them. I mean, you'd be surprised. Some people are going inching away with a V groove bit. I don't. I go full depth with a V groove every time I cut. The V grooves I use are from either Amana or from MLCS, and Whiteside and it's the other one that works really well as well. Those brands are fantastic bits. You get a good quality V bit, not one of those cheap ones, you know. And I won't mention cheap names, but you get a good quality bit. You can go full bore. I've got a 1.25 inch thick wide V bit, and it'll go down all the way to 3/4 at speeds of 80 and 120. I mean, just cutting right through. Nice sound effects. You even get sound effects here. And I've had no issues with them whatsoever. Whereas for something like a roughing pass or profiling, I will go 1/10 of an inch at a time with a 1/4 inch bit because I don't want to tear out that much. It's a V bit has a way of taking out a lot less. Let's see. When cutting solid woods, well, there's the question that I can't answer, but I'll try to answer it anyways, Patrick. When cutting with a solid wood with an 1/8 inch bit, what feeds and speeds and depth do you recommend? I recommend whatever you test to be optimal. There's the short answer. I would personally use okay, so what type of machine do you have? If you have a Shapeoko or one of these machines that use a Dremel or a little or hand carving tool, then well, that's great, but you're looking at maybe 0.05, 1/8 of an inch at a time. You got to nibble these things because it's not capable of much more. And even with an 1/8 inch bit, even the big machines, you don't want to break the bit. So I wouldn't go more than an eighth of an inch thick. I mean, the rule of thumb is half of the diameter for the most part. So if it's an eighth of an inch, don't go more than 0.0625 depth. But really, when you get into that small, 0.1 should be fine, or 0.05. 5/100ths of an inch is fine. That's for the depth. The speed, well, I got to tell you, if you're doing oak, if you're doing ironwood, 100th of an inch. If you're doing pine, you can go. You can. I mean, sorry, the speeds. That's also the depth. If you're working with pine, you can fly through that thing. If you're working with ironwood, well, then in that case, lower your. If you're working with a really hard wood, you got to talk infinitesimally small nibbles and a fast speed. One of the issues that I had with oak was I tried to go a tenth of an inch with a 1/4 inch bit with oak, and it cut fine, except it burned the wood. I had to go a lot faster than I was going at 50 inches per minute because it wouldn't go because it didn't want to cut any faster than that or cleanly. I pushed it to 150 inches per minute, but very, very small nibbles. I mean, we're talking 0.05 of an inch. And that's what you have to do sometimes to avoid burn marks. Now, if you want to sand it all later, well, that's your call. But I'll let the CNC do the work. Let's see. Yeah, see, Frankie's got a good guide there. You start at 40 inches per minute. But again, hey, John, how are you? But again, it all boils down to the material you have, the machine you have. There are some machines that are those little tiny machines that you go too fast on that thing, and that'll just bend the machine. It just won't doesn't have enough torque, whether it's the router or the frame of the machine itself. And then you have some like the Gatton CNC where I can stand on the thing and there's no limit. The only limit is the limit of the stepper motor to how much torque it has, because the machine itself structurally is a rock, or a very solid piece of plywood. So that being said, I bid you all a fine adieu and thank you all for joining me. And like I said a little earlier today, we created a template for you to test your different bits on different pieces of wood at different speeds, and visually inspect and see the tear out, see if it bogs down, listen to it as it cuts. And if you want to go through that trouble, you do that. You spend the day doing something like this with all your different pieces of wood, jot down all the numbers, and for future reference, you are going to have the fastest speeds capable. And in the long run, it will save you a lot of production time, And that's what it's all about. So you guys have a wonderful evening, and I will see you next week, and then again on May 12th. So you enjoy.